This video is on isosceles and equilateral triangles. The picture right here is an isosceles triangle. Some characteristics of an isosceles triangle that we know are the legs are congruent. The vertex angle is the angle that's created where the two legs meet. So you can see the two legs meet there. Base angles are congruent. Here's your base angles. They are congruent. The base angles are opposite the vertex angle, and this segment down here is called the base. If two sides are congruent in the triangle, that automatically means the base angles are congruent. The base angles down here are created by the legs in the base. Just the opposite of that is if two base angles are congruent, then you automatically know the legs are congruent. So if your base angles are congruent, then we know that the legs are congruent. Another thing that you know if you have an isosceles triangle is if you have a bisector of the vertex angle, which means if I come up here and I draw a line segment right here, and this is a bisector of the vertex angle, it's also known as a perpendicular bisector. So I could draw these angles down here to the base. So that means we would have equal angles up here as well as equal angles down here. So if you see a picture of an isosceles triangle where the vertex angle is being cut, where it touches the base, it has to be a perpendicular bisector. So some things you have to remember. If you see a triangle that looks like this, where just the legs are marked, you can assume that the base angles are also congruent, and then just the opposite, just looking at a picture, if the base angles are marked congruent, you have to be able to assume that the legs are also congruent. In this picture, we have an equilateral triangle. An equilateral triangle, all sides have to be equal, and all angles on the inside of the triangle have to equal 60 degrees. In this picture right here, you have these two angles marked. Well, one of the things we talked about on the other previous slide is that if you have two base angles that are congruent, then it's an isosceles triangle. So if you think about all those things that I had marked in the picture on the slide, right here, let me go back. So if you look at all these things that we had marked on this slide, all of these things that are marked, I can also mark all of this on the slide that we just looked at because it's an isosceles triangle. So since the base angles are congruent, I know the legs are congruent. This segment right here is an angle bisector, which also means a perpendicular bisector. So we can mark that on there as well. So it's a perpendicular bisector to the base. So from these marks here, we can try to answer these questions over here. AD has to equal 7 because legs are congruent in an isosceles triangle. So we have that marked for each of these legs, and I wrote 7 over here. If angle B equals 57, then angle D has to also equal 57. So we can write that on here, 57 and 57, because base angles are congruent in an isosceles triangle. Angle ACB has to be 90 degrees because it is a perpendicular bisector. So I put 90 degrees here for angle ACB because we know that was a perpendicular bisector. If BC equals 13, we know that CD must also equal 13. I'll write 13 here. Again, because of the perpendicular bisector. So we know that we have equal segments on each side. So if angle BAD, so this whole triangle, this big angle, if it equaled 60 degrees, what triangle exists? Well, this would kind of be a hypothetical question. So we would erase all of these markings we have on here and just ignore them. And now we're just looking at angle BAD. So if that were the case, that would mean that this angle right here would be 60 degrees. And I know the base angles are congruent, which means this has to also be 60 and 60. So what would we have? If they were all 60 degrees, then we would have an equilateral triangle if we ignored all of these markings. In a question like this, with this figure, I see this triangle right here. And one thing that you could notice is that it is an isosceles triangle because these legs are marked, which means this one and this one down here must be my base angles. And they have to be congruent. So these have to be 50 degrees. So we should have that on here as 50 degrees for this angle and 50 degrees for this angle. Then since there is 180 degrees in every single triangle, and these two are already 50 and 50, we would just take our 50 plus 50, and we know that that equals 100. So 180 minus 100 leaves us with 80. So we know that this angle up here must be 80 degrees. If I look over into this triangle, on this side, this 50 degrees and this angle here are supplementary, which means they have to equal 180 degrees. So if this angle is 50, we would just take our 180 minus 50, and I get 130. So I know that this angle here is 130 degrees. Then if I look at this triangle, that's also an isosceles triangle. This one and this one are my legs, and this 130 degrees would be my vertex angle. So if I take the 180 minus 130, which is my vertex angle, that equals 50 degrees. And since this angle and this angle have to be my base angles, I can take 50 and divide it by 2, which gives me 25. So this angle has to be 25, and this angle has to be 25. And so we've solved for all of our angles here. In this picture here, you should see two different isosceles triangles, each with their own base angles. Just to take a look at it, if I look at this big angle right here, triangle BAC, or angle BAC, sorry, this big angle right here and this big angle are triangle ABC's base angles. Then if I look at triangle BDC, that in itself is also an isosceles triangle, and this angle and this angle are its base angles. Just make sure you pay attention when one triangle is inside of another. Pay attention to which ones are the base angles. Based on this figure, we can figure out the answers to this and figure out the congruency. So, segment AF has to be congruent to segment AD. So we'll write that over here, segment AD. Segment BE, right there, has to be congruent to segment DE because those are labeled for us. Angle ACB, so angle ACB is congruent to angle ABC. Angle D, we could also say here, angle D would be congruent to, right there is angle D, would be congruent to the other base angle E. And segment BD, right here, segment BD, would be congruent to segment BE because you can see that these would all be equal. So we would put here segment BE. Definition of isosceles base angles are congruent and legs are congruent can also be reasons in your proofs. So in this case right here, we're given triangle ABD is an isosceles triangle with A as the vertex angle, and then also CA bisects BAD, angle BAD. So once I'm told that something is isosceles, we know legs are congruent, base angles are congruent. That is the truth in every isosceles triangle. So down here in my proofs, what I want you to do right now is see if you can mark this isosceles triangle according to what's shown here, and also state your reasons that go along with these statements. So AB is congruent to AD. So AB and AD, I marked those up here because I was told that it was an isosceles triangle. Angle B and angle D are congruent, so I know that those are congruent because of the definition of an isosceles triangle. In this case, since I've already identified that it's an isosceles triangle, one of the things I know about an isosceles triangle is that the base angles are congruent. So in this case, base angles are congruent could also be used as a reason right here. Angle BAC is congruent to angle DAC. Well, up here we were told that CA bisects angle BAD, which means this has to be congruent to this. BAC is congruent to DAC. So these are marked congruent as well. So that's a definition of a bisector. Then triangle ABC, right there is triangle ABC, is congruent to triangle ADC. And if we look at this, we've got, for our theorem, angle, side, angle, and angle, side, angle, which is what we put down here for our theorem to prove that those two triangles are congruent.